Hi, it's Sparky Pete in Liverpool. Come today from the isolation wing of Peacock Towers, and I'm going to take you through ZE testing. ZE is your external earth fault loop impedance, which is effectively the impedance of the line and earth back to the substation. The first thing I'm going to emphasize is the fact that it's a live test. Now, a couple of things. Electricity Work Regulations basically says, I'm summing it up here, is that we do live tests if there's no alternative. Well, here, the only way that we can take a measurement of the ZE is to do a live test. So this is one of those situations where there is no alternative. The other thing as well is that you'll see when I put the line probe on that I'm using GS38 approved test leads, and that's the subject of another video. Also in the guidance, another thing to realise is that we can do this test as an alternative to an earth electrode test. That's in the regs and all the guidance as well. If you think about the setup, the installation is isolated from the supply. Now, do I need to lock that off? Well, again, you know, all of these things, before we bowl in and do this, there's a whole load of things to think about, isn't it? As I've mentioned all the time, risk assessment, method statements, notifying people, permits to work, all the rest of it. Now, at the back of our minds all the time, we're currently, you know, we're always doing a risk assessment. Now, in these circumstances, I'm happy that this board is under my supervision, and that it'll stay under my supervision until I've finished the test and I've got the covers back on, and the test has all been done. So that's another thing to say. So the board is isolated from the supply. The consumer is isolated from the supply, and one of the reasons is we've got the earthing conductor disconnected, so we don't want to risk people using the installation, obviously, with the earthing conductor disconnected. So that's the setup. If I go ahead and do the test and then talk a little bit more, there's the value that I got previously on the meter, 0.23 ohms. Now let's see if we can duplicate that. With these tests, they can jump around a little bit. So with these kind of one-shot tests, you're probably best not to make them a one-shot, or maybe one-shot test, or maybe, you know, take a second confirmation. So let's see if we get that value again. Now, this ZE test would have come after a confirmation that the supply polarity is correct. And the other thing to say about that is that we get a supply confirmation, supply polarity confirmation with every live test that we do in one way or another. But what it recommends in GN3, and I can see why, is that we do the polarity confirmation with a voltage indicator, just again because it's clear and unambiguous. We haven't got dials to set up, etc., that we could get wrong. Anyway, enough talking. For now, let's have this. So the test has gone off. Let's try again. That was good, wasn't it? So enough talking for now. Let's go ahead and make the test. So it's telling us there, less than 55 volts, because obviously it's not at the moment connected to the supply. When I put the probe on, it's going to initiate automatically. Let's have a look at that. So I'm getting a 236 volts, 0.25. So our ZE is 0.25. Let me just take that again. So what have we had so far? 0.23, 0.25. Let's go again. 235 volts. 0.23. So back to that again. I would take out of those, obviously, the worst case scenario, which is 0.25. Now, once we've taken that value, what are we going to do with it? Well, the reason why I forgot to mention, the reason why very importantly, why the earthing conductor is disconnected is to remove any parallel paths, to make sure that we're just testing the ZE and nothing else. We're not testing earthing through pipework or other means. It's just that incoming earthing conductor connected to the means of earthing. I mean, it says in the guidance to disconnect. Well, you could disconnect it from the means of earthing and take the reading to the means of earthing. Well, the main point of it is that, you know, we don't have any parallel paths concerned. We're just testing that the earth fault loop impedance of the supply, independent of any parallel path through structural steelwork, etc., is bona fide. And it also mentions in GN3, for example, that we could determine this value by inquiry to the distributor. Now, that doesn't mean you get on the phone and ask them, because the inquiry values are generally, well, they're known. So this is a TNCS earthing system. If we get an inquiry value, and they're going to tell us 0.35 for that. But what it also says in GN3 is, even if we rely on an inquiry value for the value, we've still got to determine that, well, what's the actual word? Let's have a look what it says there. It's telling us there, however, if this is relied upon, a test must be made to ensure that the distributor's earth terminal is actually connected with earth, using an earth fault loop impedance test to verify that the intended means of earthing is present and of the expected value. So there we go. So we expect it to be 0.35 or thereabouts, and we're getting 0.25, you know. So normally in this situation, we're going to measure the value. It's going to give us obviously greater accuracy. What else to say? I mean, once we've determined that ZE value, we can obviously then use that to calculate ZS. We could add that value to R1, R2 and determine our ZS that way if we choose to. And when we compare, I mean, I need to sort of cover ZS on its own, really, the comparison of it or the verification of it. But when we compare the ZS values for the different circuits, then something to realise is that we would only ever take 80% of a value in the regs, because that is at the operating temperature of the conductor, and the values in guidance note 3 and the on-site guide are 80% of what it says in the reg. So if you've ever looked at that and wondered why there's a discrepancy, that's the reason why. Sometimes people say to me, well, there's no point in disconnecting that earthing conductor from the means of earthing, because I'm getting the same value whether it's connected or disconnected, and I've just tested that for myself again, just to remind myself what the score is with that just before, not to remind myself, but just to kind of run through that myself. And indeed, I was getting the same value whether it was connected or disconnected. But what I say to people is, if we haven't got a bona fide means of earthing, then you can bet your bottom dollar you get a different value then, because if we don't have a proper earth coming in, we're going to get open circuit. So those two values, you would get open circuit when the earthing conductor is disconnected, and you get what's called a fortuitous value, or a fake value, if you like, for ZE when the earthing conductor is connected, because obviously you're getting it through all the parallel path. Now, some of you might want to say something about the gap there between the gas service and the consumer unit, and I'll talk about that in another clip. I'm going to do a clip where I just talk about, you know, what we're looking at in front of us here, and what information can be gained just by looking at the installation. So there we go. As always, constructive criticism appreciated, because nobody knows everything, and there's always more to say.